welcome to .NET Days CZ meetup. My name is Jakubianis. I would like to welcome all of you to this 1 hour of our regular meetups where we talk about .NET stuff and the problems we face as .NET developers. I hope you are well, staying healthy, and excited for this time that we'll stay together. Today's speaker is Michael Staib, the author of Hot Chocolate and a co-founder of ChilliCream, a company, and we'll talk about GraphQL, the protocol, and how you can utilize it to make your APIs smarter and nicer to use. Michael will be here in Update Conference live in Prague. So if you want to meet up with him and ask some questions face-to-face, you have the opportunity this fall. And for this talk, if you want to shoot up some questions, just write them up in the YouTube chat, and we'll go over them at the end of the talk. Or if it's relatable to what Michael is talking about, some of them he'll answer right away. That's all from me. So Michael, without further ado, take it away.
Hi, I'm Michael Staib. As introduced, I'm one of the co-founders of ChilliCream and also one of the co-authors of the Hot Chocolate GraphQL Server for .NET. Today I will talk to you about getting started with GraphQL in .NET. And we will explore GraphQL as a protocol in the beginning, and then dive also in how we can build GraphQL servers and communicate with GraphQL in the .NET space. All what I'm showing you, the tools today, are actually open source. And everything you can find on GitHub. If you like what you see and if you like our work, then please provide us with a GitHub star. It's the easiest way to give open source projects, not only ours, but any open source project you use, some little contribution. With that, let's start with getting started with GraphQL in .NET. So when I talk usually or engage with people in the .NET space about what GraphQL is, then often we get a reaction like this, where people say, what the fuck is GraphQL? Or is that actually OData just from Facebook? Or something like that. And it couldn't be further from the truth. So GraphQL is nothing like OData. And we will explore why that is, and also where there might be overlaps. So GraphQL in other technology stacks like JavaScript is hugely popular. Like in the JavaScript ecosystem, if you go to JavaScript developer, almost every one of them knows GraphQL. And I would say most of them are even using it. So what is GraphQL and where does it actually come from? So GraphQL originally was developed by Facebook back in 2012. And they started work on GraphQL actually for a very specific problem they had with their mobile applications. So back then, Facebook faced a lot of criticism about their mobile applications. They were too slow, they used a lot of data, and they burned through your battery in minutes. It's a bit over-exaggerated, but essentially the experience with the Facebook mobile applications back then were quite bad. And that was not because of Facebook being very bad at implementing these applications for mobile. For the mobile space, it was essentially because Facebook took what they knew from the web area. So they took the knowledge that they acquired for building their web portal and built with that mobile applications. So they tried to use web technologies to build mobile applications. And if you think today, we have React Native and stuff like that. It's really, you take web technology to build mobile applications. So, but back then they used essentially HTML and REST to build these new mobile applications, and they got very bad results. Why that is, we will explore in an experiment later. So first, I want to dive just with you into some GraphQL syntax. Then we will explore what actually the problem is Facebook tried to solve here. And then dive in to what GraphQL is, what it's not, and look at some .NET code and how to build a GraphQL server. Okay, let's start. This is essentially the hello world of GraphQL. It's a very simple query, and it asks our GraphQL server for the currently signed in user and for the name of this currently signed in user. It almost looks like JSON, and that is essentially what people mistake it for when they first look at it. Looks like an empty JSON graph, but it actually is also a good analogy, because if you send that to a GraphQL server, the GraphQL server would respond with a message that almost looks like it fills up the empty JSON graph with some data. It's not like that, but it's a good mental picture to start thinking about GraphQL. So you define what data you want, and the server essentially fills up your query with the data you want. But GraphQL is not only about very simple data structures, and you can drill into data further. Like if we were to build components in our front end, and now we just have a simple component that just shows the username, and then we want to expand and also integrate the profile picture, we could just change our query or create a new query that then really drills into more data. For instance, we want to, as I said, fetch the profile picture here. And from the profile picture, we want the width, height, and URL. And as we expect now, we get a response that closely aligns to our request. And that's neat. And if we think that further through, it's not about flat data structure or simple sparse fields like we already have in REST or some other approaches. It's really about trees of data. And this allows me to not only get things that are specific to the user, but also things that may be related to the user, like maybe the friends of that user. So I can drill into related objects of the currently signed in user and fetch that in my request. And again, the server would respond with something that very closely aligns my request. But we already can see here some repetition, like name last seen is used twice, because once we have it for the currently signed in user, which is a user object maybe, and then we have the friends list, which is a list of users maybe. But in GraphQL, we have a solution for those repetitions. And these are reusable data shapes. We call them fragments, and they are the primitive for composition in GraphQL. They allow us to create fragment hierarchies as we create component hierarchies in our UI components, or class hierarchies in our backends. We will explore the GraphQL syntax deeper over the talk. That was essentially just to get you a bit started with how does GraphQL look and what are the key benefits. When we think about REST, then we always talk about things like resources. When we think about GraphQL, it's all about queries or a GraphQL schema. I've created a little task we will work through now in my first demo, where we explore a bit the key differences and the problems or the struggles Facebook essentially had with their mobile applications when they started working on GraphQL, and essentially that is the reasoning why they started with working on GraphQL. So there is a very popular example in the GraphQL space, and it's actually the Star Wars API. So every implementation has a Star Wars API example. And that is because there was a page swappy.co, which essentially is now the swappy.dev here, which showed how to build well-formed REST APIs. And they did it with Star Wars data. So what we want to do here is to create a simple or fetch some simple data. We want to fetch all the characters that appeared together with Luke Skywalker in movies. So all the characters that appear together in movies with Luke Skywalker. And we will do that by using this REST API, and we will do that by using our swappy GraphQL API, which is the same data, essentially just a GraphQL layer over REST to do the same thing. So as a backend engineer or as a front-end engineer, you should be familiar with REST. I think that was what drove the past 20 years or so. At least everything past SOAP was REST to me. And so it's easy to engage with these APIs. If we look at our REST server here, we can see it exposes some resources. As I said, REST is built around the concept of resources. Resources are essentially exposed as endpoints. So we have, for instance, here a people resource that is exposed through this people endpoint. And then we have other endpoints for other resources: planets, films, species, vehicles, starships. So everything related to the Star Wars universe. If I would fetch the people endpoint here, so if I would do a HTTP GET on the people endpoint, I would essentially get a list of people. And that is what I would expect from a well-formed REST API. If I just ask for the resource, I would get the list of objects that resource provides me. And if I look at this data, it's well understandable for us. It's JSON. We have some attributes here like name, height, mass, hair color, and what have you. But then we also have some special data here, which is these URIs. Like films, I have a couple of URIs. Vehicles, I have a couple of URIs. These are essentially references to other resources. In this implementation, they are modeled as URIs. They could also be just IDs that I then take and ask another REST endpoint for and get a new object. So essentially, if I call one of these URIs, I would get to the object that is referenced here. Also in my list, I can see I have here this URL, which is referencing to myself. So if I would grab that, fill it in here, I would get just the Luke Skywalker object. So the initial thing we want to do is fetch all the characters that played together in movies with Luke Skywalker. So the best thing would be first fetch Luke Skywalker, right? And then maybe get the films, because we want the characters that play together with Luke Skywalker in films. And then we could drill into the films here. So fetch the next object. And then we can see in the films object, again, a lot of attributes, well-formed JSON, we can read that. And then we can see here the characters. And then there are the characters that appear together with Luke Skywalker in this Star Wars movie. if we would fetch these characters, we essentially would get them and could extract from that the name. So it's a simple algorithm that we could write here to build this simple fetch call. So if we look at a bit of JavaScript I've written up to have a little benchmark between GraphQL and REST, we can see that the algorithm to fetch the data to form this list of characters here is quite easy. We essentially, as I walked you already through the endpoint, would through the REST service, would fetch the character 1, people 1, that is Luke Skywalker, then iterate over the films, fetch each film, iterate over the characters array in the films, and then fetch each character and essentially do a bit of data massaging and push that character onto my character array, and then display the list of names. So simple algorithm, actually. If we go back and we would run that algorithm in our browser, we would get around 3.9 seconds on my 1 gigabit internet connection. Not bad.
Michael, could you please make your fonts a little bigger? It's
yes.
A little harder to read on the YouTube stream.
Okay. Let me make that bigger. Now I essentially deleted my results, but we can rerun them. So you can see it's not fake. Okay, now it turned out 2.5 seconds. So there's no caching here, and also the pre-flight checks are not so expensive this time. But still, we have 2.5 seconds here. Not bad, a lot of data. But what we can see here is that we have a lot of fetches. So first we fetch Luke Skywalker, and then we fetch all the other requests. And worst of all here is that it's essentially a waterfall that we designed. We have these HTTP calls that depend on other HTTP calls. We have consecutive calls, and that means we cannot parallelize these calls properly. Also, it's quite a lot of calls. How many did we? 124 requests. That's quite a lot to just get this list of names. And if we take into that calculation also the bytes that we transferred, it's quite a lot. And that actually is what happened to Facebook's mobile application. They worked with a very well-formed REST API. And they had all these calls because they logged in. They fetched the user, then they fetched the user list, they fetched the stories, then they fetched the comments to the stories. So you had all those calls that depended on other calls, and it was a very slow experience. And you came out with thousands of calls. Just in that small example, I already produced 124 requests. Okay, so how would we do that with GraphQL? So we already saw a bit of GraphQL syntax. Just get that out. And the syntax is very simple. And the best thing about GraphQL, before we write any syntax, we can explore our GraphQL schema. So this IDE here is... and let me make that also a bit bigger. This IDE here is called Graphql. It is the original GraphQL IDE. And we are using here the official GraphQL Swappy example. So this is not Hot Chocolate or anything .NET. This is GraphQL.js. So before I go into my API, into my Swappy API, I can actually explore it. I can see there's a query root type. I can dive in. I can see that there is lots of root fields like all films, film, all people, person, and so on. So I have all the things that I actually can do in my REST API. To write the algorithm that we wrote with our REST endpoint, we would essentially start with a keyword query here. And then we would use our squiggles, our braces here, and could dive into the data. So I already saw here is a person field. So we could just dig into our person field. I can see that it requires an ID. And then I could drill in. Maybe I just get the name first. So we want the name of our GraphQL, of our Luke Skywalker character. So we saw that the actual ID in our GraphQL, in our REST API was just an integer 1. In GraphQL, we also could have the integer ID, but they are using something called the global ID pattern, which makes this ID unique for the schema. I'm not going into that too much, but that essentially is our one that we had in REST. Okay, so what I'm doing here is I'm fetching just the person Luke Skywalker, and from that person Luke Skywalker, I'm just getting the name. And boom, it's there. I have just the name of Luke Skywalker. Okay, that's awesome. And I also can see that I actually can drill into more data. So if I have my person object here, I can see that we have something called a film connection. And this is how I can drill into my films. And you can see there in our references, I actually can drill into that object. I can fire that up and I get my data back. Okay, but it gets better. I can drill even further in and maybe get the character connection here and get the characters and get the name of the characters. Fire that up again. Awesome. I have essentially built up my name. But we actually have too much data. We just wanted the name of the characters that play together with Luke Skywalker. So we can get rid of this one and this one. And then we actually have the data we need. And the beauty of it, I don't have to write any algorithms in JavaScript. I actually just fire this GraphQL request. And in 250 milliseconds, I get the data from my GraphQL endpoint without writing any client logic to aggregate data and fetch more. I just do one call. I get all the data. I don't get all the data transferred that I don't want. I just get the data that I want. Okay. Head back to my slides and go on. So with GraphQL, we only have one endpoint. And that's opposed to REST, where I have all those endpoints for all my resources. So each resource has one endpoint. I always have to keep all my endpoints around to know where to fetch what data. With GraphQL, I just have one. And I can get all the data I need in one request. Essentially, for all my use cases that I have, or for my components that I build, I just can gather up one request. Or if you think about the Facebook mobile application, the Facebook mobile application now can just craft one request that drills into the users and stuff like that, and then just does one request to the server and gets the data immediately without all those aggregations on the client. And that really is enhances the network experience between the mobile application and the backend on also crappy edge connections or 3G connections that you have. There are also ways in GraphQL to deprioritize fields in your query. So you essentially can tell the GraphQL server, okay, I want all this data in one request, but these data parts are not so important. So the GraphQL server will stream the important parts first and then get maybe more expensive fields later and stream them down as you need them. With GraphQL, we don't have over or under fetching problems on the client side. And that's important. We might have over or under fetching still in the backend, but that's not so important because the expensive network traffic is between the consumer and your backend. So the mobile application that is used in the bus on the commute that tries to fetch some data over maybe a 3G connection, that is where your bottleneck is, not in the backend where you have the servers close together and might do some overfetching. So what is overfetching? Overfetching was when we got the Luke Skywalker request from our REST API. We got all this data from our REST endpoint that we didn't even need. What we wanted were just the references to the films. And fetching the films also was overfetching because we didn't need the film object. We just needed the references to the characters. But also the character fetching was overfetching because we actually just needed the name and not all the other data. And what is underfetching? Underfetching was also in all of our requests. Since when we fetched Luke Skywalker, we overfetched, but we also underfetched because we didn't get the data that we actually wanted. So every time you get not enough data, that's underfetching. Every time you get too much data, it's overfetching. GraphQL is built on a strong type system, and that is opposed to something like Swagger. So essentially REST with Swagger combined. Because REST and Swagger, while exposing a schema, is not enforcing the schema. It's not a proper type system. It's like you are creating the schema either by hand or you're generating it from your code. But essentially, after it's generated, there's no enforcement. So if you violate, maybe because of faulty server code, some of the contracts, sent down an int for a string or sent down a null for a non-null field, then this is not caught. It will break in your client, in the consumer. With GraphQL, we have a proper type system and an execution engine that enforces these type specifications. So the schema is not disconnected from the runtime. And that makes GraphQL predictable to use for the consumer. So if you would violate a contract, the GraphQL server would actually fail the request. It would say, okay, there's something wrong in the server. I cannot give you the data for the request because there was a violation. And this allows the front-end developers or the consumer of your data to trust in what the schema tells them. On top of that, GraphQL is real-time, meaning it's not only just simple get and post requests. It's really real-time requests where you have a socket connection maybe or other stream-related connections. And we are passing along query results in real time. Let's look back at REST for a second, because we can also build very optimized requests in REST or introduce something like sparse fields. I already mentioned this term. But if we would do that, we would often end up with these very complicated requests. This is an Amazon Shop API request. And just let me tell you, Amazon is actually one of the biggest GraphQL customers in the world. So they are really pushing on GraphQL. But still, this is one of their REST requests. I actually looked them up in their documentation 3 or 4 years ago. Maybe they are using only GraphQL now there. I don't know. But if you look at the request, it already looks very complicated. And it exposes data where it's not clear what data kind it actually has. Again, you can have a REST Swagger schema there that explains this, But still, you still have to construct these these requests in the end. Also, with REST in place, there's always back and forth between backend and front-end developer. With REST, every time our front-end changes or we have a new use case, we essentially need to talk to our backend engineer and get a new request or get a new option there to get more or less data. The typical example would be here that you're building a web page at the beginning, and then like Facebook, you might want to take this web page and move it to mobile. And then for mobile, you want a bit smaller request, so you want to omit some fields that you fetch maybe. And then you're going to your backend engineer and asking to change the request. And you have this back and forth between backend and front end and have to iterate together. And that often goes wrong. So maybe there are misunderstandings and stuff like that. With GraphQL, you would just kick out the fields of your request, and then you have you're done with it. But with technologies where these requests are essentially built before the use case or built for a different use case, you always have to then issue more specific requests or always iterate on your backend to feed new use cases for the front end. And with GraphQL, you essentially expose the world, expose your business model to the public. And then the front-end engineer can pick and choose what he or she needs from your schema and build their application with it. So what is GraphQL? So when we look at how Facebook explains GraphQL when they initially built it, then they say GraphQL is actually a thin layer over your business layer. And this is actually a great way to build GraphQL servers. So you have a strong business layer, a good domain logic. And then you can use GraphQL as a thin layer over it to express your business model to the world. You have this nice monolith of GraphQL to dig into your business model. It's essentially GraphQL makes it human readable, human explorable, these data. And GraphQL has all the tools to make that happen because we have unions, we have interfaces, we essentially have all the elements that we have in our programming language. So GraphQL is a very good data definition language. And that is different to things like REST, where you always have to copy our things in DTOs and expose these DTOs. And it's just because our service layer cannot express it, has not the means to express what we actually express in our business model. And that makes them unreadable. With GraphQL, we don't have this limitation. It's very expressive. But as GraphQL became open source and other people started using GraphQL, apart from Facebook, it turned out that GraphQL is also a great gateway that you can put over your old or new infrastructure and have this nice monolith to interact with the data, while behind that thin layer of GraphQL, you actually have microservices or your old REST services, gRPC services, what have you. For instance, Netflix uses GraphQL, and they use it in combination with Thrift. I think it was Netflix that used it with Thrift or Twitter. I don't know. I might mix that up. But the point here is you could have other technologies, other approaches to your services, like microservices or monoliths. It doesn't matter, but you have it behind a little layer of GraphQL, and GraphQL is actually the way to interact with these. It's some kind of compensation for this push to microservices. So what is GraphQL? GraphQL is a query language for your API, and that is a mental model behind it. If you think about things like OData actually comes from the space of databases. It's a filter language, if you want. want to classify it. It grew over the time, but it actually started from the databases. And you had all those things like, I don't know if somebody remembers, they had this ATOM-PUB protocol, which was XML-based back then. And you still can see it's spawned off databases. GraphQL is different. It comes from the mindset of application of an API of those. So you can see it's made to expose a proper business layer, not just some raw data that is in a database. So it has a much more elements to express data. And that actually, if you show GraphQL to a front-end engineer, or even I would say if you show GraphQL to data analysts, it sells itself. Because people just sit in front of it, they start using one of those GraphQL IDEs, they can drill into the data and just explore it how they want, very arbitrarily if you want. And that actually has the opposed effect on the backend engineer. And I think if you look at where GraphQL is very popular, it's very popular with JavaScript engineers. That's because a lot of them are building front-end applications. And then we look at people that are building backends, like .NET engineers or Java engineers. And then you have the opposed effect in the beginning. People think, oh gosh, this is horrible. They cannot query my server however they want. That will have horrible performance impacts. And how do we protect our database? How do we protect our backends? But actually, GraphQL is an opportunity for us backend engineers. And if you look at the creators of GraphQL, two of them are backend engineers. And they created it with a backend perspective. So GraphQL gives us the opportunity to really mold how consumers access our API. And as I said, GraphQL is a great data definition language. So it gives us all those capabilities to define how data is structured and how you can access it. So actually, we still are in full command of what we expose there. It's not like we give them a database. We actually expose our business layer and define the interfaces that the user can use. And we can also put in like cost constraints. Like we can say, okay, this field is more expensive, and actually the user has like an allowance to have this has a performance impact per query of maybe 1,000. And then if you calculate the field cost, you can even before executing the query deny the request because it's too expensive or something. You actually have more control over your request and the data structures. So I would see GraphQL for the backend engineer as an opportunity. So how do GraphQL operations compare then to something traditional like REST? So if we look at the operations that we can do in GraphQL, we have a read operation, which is the query keyword. When we write that in front of our queries, we essentially can do side factory reads on our GraphQL server. It kind of is a get in REST. And then we have something like the GraphQL mutation, which causes side effects on our backend. Changes data, so we are writing data, and you could compare that to put, post, patch, delete, and what have you in HTTP verbs on REST. But then we also have something called subscription, which is actually real-time events, and we will look at them later. And that we don't have in REST. I mean, we have things like WebSockets, and you could have things like Signaler and stuff like that, but that's not actually what what REST is. It's just another protocol that we put on there and that we could combine with REST. But in GraphQL, it's fully integrated, and you will see in my demo what I mean with that. So GraphQL, if you look at these three operations here, you can also see that it will work very well with things like CQRS if you are a fan of that. Before we go into another demo here, let's also talk about what GraphQL is not. So GraphQL is not a graph database query language, and GraphQL as a name is actually people almost immediately think of graph databases. And don't think about a way to query your APIs. It actually, fun fact, Facebook, I think the initial version of GraphQL was called Supergraph. Yeah, I like GraphQL more, but it also has this confusion about it. And speaking of databases, GraphQL is actually not bound to any specific data source. So you can use it over anything. As I already showed you can use it over REST services, gRPC services. It doesn't matter. It's for APIs. And it's not Facebook's version of OData. And you should already infer that. Even if you're just so on this simple query logic now, you should already have the sense it's much more than OData. It's real time. It lets me drill in much deeper into those APIs. We also don't have to have a single route like that, what you have with OData. You're not limited. It's not a database filter, essentially. It is much more. But we will also see in the demos later why it's so much more. Also, GraphQL is not a good solution for binary streams. And while Netflix is one of the companies that now solely uses GraphQL to interact with their backend, they're not using it to stream your movies. They're using it for everything related with data. So GraphQL is good with data, structured data, related data. GraphQL is very good for that. But it's not good for binary streams. So if you have something like large downloads, don't do it in your GraphQL request. Actually, you could expose the link to something in GraphQL, and then you would download it just as a standard HTTP stream. Also, like the streams, you have super protocols for doing movie streams. GraphQL is not something for that. And GraphQL is also not limited to HTTP. And we are also working on GraphQL over gRPC at the moment for version 13 of Hot Chocolate. For specific use cases, so when you do schema stitching, you can then upgrade your calls to GraphQL over gRPC to have more efficient communication between the GraphQL gateway and the GraphQL downstream services. So GraphQL is not limited to using HTTP, and it's also not limited to JSON payloads. The GraphQL specification actually doesn't even talk about how the transport is being handled. And GraphQL is also not limited to the JavaScript world. In fact, if we look back at the example of Facebook, we saw Facebook is using it for native mobile applications in the end with Swift and Java, and they used, I think, PHP in the backend back then. So there was no JavaScript involved in the first version of GraphQL. The fact that it's so popular in JavaScript is because the reference implementation for the open source version was then written in a JavaScript, GraphQL.js, and it really, if you show it a front-end developer and show him the capabilities, what you can do with GraphQL, they will just take it off your plate. So let's start with some .NET code. I talked now a long time. Let's do some proper coding. I prepared a little demo here. This is actually an empty ASP.NET Core server. So it's at the moment .NET 5 still, but it already works with .NET 6. There's actually nothing in there except the Hot Chocolate ASP.NET Core package. And let me bump the font size up. I hope this is better. Yeah. Okay. So as I said, nothing in here. So we have just one route mapped. It will just return hello when I call this endpoint. Let's do that and run. Call localhost 5000, and we can see it just returns hello. So what I told you is that GraphQL is actually for APIs. And in order to have something here, we would need some models. So there's a popular example that people do with books and authors to create essentially a very simple service. And we are just going to do that. Let's introduce, for instance, a book class like this, which essentially has two properties, title and author. So this is our API. And if we want to query that object or expose it through GraphQL, we would need to provide something called a root type. And a root type is essentially what is your operation. So I told you these operation: query, mutation, and subscription. And in GraphQL, you need essentially a root type for these. And this root type, let's call it query, exposes what you can do. And that is also one thing backend engineers in the beginning, when they think about GraphQL, they are afraid of people just querying your system. But it's not like that. You essentially have these root types. And let me just put the query type in. And this root type, they expose essentially functions or methods in this case. And these are your root hooks into data. So you can call getBook here and then drill into the data from there. And that puts you really in control of how people query your data, because you can decide how they can really drill into that. So this is my root type. It's just simple C#. You can see it's just a class, and we have here method that essentially just returns the object book here, and has some data here for the book. Okay, and we now we cannot just run it. Not that intelligent. So we essentially have our API ready, and we have our root type ready. In order to make our server GraphQL Server, we actually have to put a GraphQL Server in our DI. So the GraphQL Server is transport agnostic. So we need to set a GraphQL Server up. That's the first thing. We say add GraphQL Server. With that, we would have a GraphQL Server that is actually invalid because we don't have a root type here in our DI. The next thing is we can chain in that we want to have a query type. And the query type is based on our C# plus query. With that, we have a valid GraphQL Server sitting there, but we also need to have some execution layer that executes HTTP requests on our GraphQL Server. So we use this endpoint API from Microsoft here to map our GraphQL Server just onto the default route. We could specify the route, but we're just going with the defaults here. Okay, so with that, we can run our GraphQL Server. Just go in private here. And then we could call our API the localhost here. And the default route for GraphQL is actually /GraphQL. And we are greeted with this IDE here, because we detect, okay, that you're accessing this with a browser. And we give you a GraphQL IDE called Banana Cake Pop, which goes well with our Hot Chocolate server. And this allows you to query your API. So in order to get a new tab, I can just hit enter here into my UI. And then I'll get a new tab here. So here I can write my queries. And here I will get my responses. Let me also bump that a bit up. So, okay. But I also maybe want to explore first my schema. So I can go into my schema reference, and I can see that I have a query type here. And I actually exposing here one field called book. So we call the method. And the method actually in GraphQL terms, we are talking about resolvers here. The resolver is getting the data. It resolves the data for us. So our resolver is called getBook. But in GraphQL, we don't prefix our fields. These are called fields in GraphQL. We are not prefixing with get. We should call them book or books by ID or something like that. Or all books, things like that are okay, but we shouldn't prefix them with get. So what Hot Chocolate does is applying these GraphQL best practices just on your classes to make this a nice schema. But you're always in control to override these defaults. And we already can see it's non-nullable, so it detected the non-null reference types from C# and translated it correctly. And I can read into this book, and I can see I have an author and a title. Okay, that's awesome. I can essentially discover my schema. Very nice here. And I also can start writing my query. I can drill into book, and then maybe just fetch the title and run that. And then I get my GraphQL request here and see that it's actually C# in depth. Or maybe I get the author, and then I get some more data. And you can see that I cannot just query anything. I just have to go through my root field. So the backend engineer is in control. Okay, let's get out here. That was the first example. Awesome. We built our first GraphQL server in .NET. And consider how easy it is. Just created some APIs there, just plain C# code. But okay, that was simple. What about Entity Framework or other frameworks? MongoDB or some other data frameworks. We could also ask, what about REST? But what about Entity Framework is actually the thing most .NET engineers ask immediately. How can I bring my Entity Framework in? Let's have a look at that. Let me get rid of that here, because it's super simple. And let's get into our second demo. Demo 2. Restore. I don't know if it was restored, but let's make sure. Okay. So actually, this is again a GraphQL server. It's not a lot different than our initial. We also have our query here, get book. Essentially, what we have before, but you can already see there we have a database here, and we also have some entities lying around. So we have book. And book actually is now a proper entity that also has here referenced author, and author references back to books. And then we have a DB context that explains how the database works, how the relations work, and stuff like that. Okay, that actually works everything. We have the models there. But how do we refactor now our GraphQL server to use the database and take advantage of the database? So the first thing is, let's go to our configuration, to our startup CS. Just get rid of that to have more space. So the first thing we actually need to do is to put in a DB context. So we need a DB context registered with our services. So we can say add DB context, and we essentially put the DB context in here, put the connection string in, and then just so we can see what happens underneath, I put in a logger that actually prints out the SQL statements that we are firing to the database. Okay, with that, the DB context is set up, and we can use that in our GraphQL services. The next is, let's get here to our query type. Let's get rid of our old resolver and put a new one in called getBooks. And what we are going to do is we are injecting this book context here, and we are annotating it as a service. So we want a service called book context, and then we just return that as a query. Okay. Let's run that. We just changed 2 lines of code. Let's go back here to our GraphQL. Here. Okay, our schema is there. Let's explore our schema. Let's expose our schema. We can see that we have now books. And we can drill into the book. We can also see that we have now author here. So we have all the relational data. They are all connected, and we can drill in forever. And we also can now query this stuff. So we can go in books, title, and we also can get into the author and query essentially the name of this. And then we fire it up, and then it didn't work. We get author is null. Okay, so what happened here is actually that the GraphQL server understands there's a queryable, and it understands that there is data. So it understands that's a list, and it can fetch it. But it doesn't understand about these objects that are related to it, so it doesn't know that it can actually project into it. If you look at the SQL from our request, we can see that it actually selects just the ID, the author ID, the title, so everything from our books. So it also doesn't know what we actually selected. So it didn't understand that we selected title and name. Queryable at the moment is just a simple list for it. Okay, so we need to tell GraphQL or Hot Chocolate about that we are using something like Entity Framework here. And this actually we can do with another package, which is called the Hot Chocolate Data Entity Framework package. And as I mentioned, we also have packages for MongoDB and also just for queryable. So you can take Hot Chocolate data and it just understands already queryable, or you can more specific get Hot Chocolate data Neo4j for graph databases and all these other things. So there's a lot of packages around to teach Hot Chocolate some more specific database stuff. And yeah. So let's teach it about our entity model a bit more. So what we want to do here is we want to be able to drill into the data. We want to be able to translate GraphQL queries into SQL queries. And we can do that with a middleware. And this middleware called use projection. And this use keyword here indicates that this is a middleware, and then this middleware is applied before into this field pipeline that we are executing here. I will show you a diagram in a second, and that makes it very clear. But maybe we also want to filter in this database. We might want to have something like where clauses and stuff like that. So we could say use filtering. And we could do something like use sorting. And since we don't know how much data there is, we might want to also say use paging, right? So we get all those things in there. Awesome. So now we have actually a pipeline. And let me go back to my slides to explain it a bit. So these middlewares are essentially a way to manipulate the pipeline that executes this field. So what these middlewares do essentially is applying new logic on top of it. So initially they will just yield to the next middleware because the field is called. So use paging is the first middleware that is executed because it sits at the top. And then essentially it will just yield to the next, and all the other middlewares will also yield to the next. Then the resolver is hit, and the resolver will return the queryable back to our system. And then the sorting middleware will actually apply sorting logic on top of it. And we will understand that when we actually write the GraphQL query in a second. And then the sorting middleware returns the new queryable that now has this new sorting applied on top of it. And then if filtering middleware will apply filters on top of it, return the new queryable that now has filtering on top of it. And then the projection middleware actually will apply projections on top of this new queryable and return again a new queryable that has this projection logic on it. And then at the end, the paging middleware will chop this apart. These middlewares don't have to go together. You can just use one or the other, and you can intermix them with middlewares that you create or that other libraries create. Okay, but this is good. We have one more thing to do because we need to tell our schema that we now are using these middlewares. These middlewares need providers that provide logic to it. So we just go here and say, okay, we actually have a filtering, and this will just put in the default filtering logic that we have for queryables and stuff. That's also add Mongo filtering or stuff like that if you have the Mongo package. So we are saying also add sorting, and we could say add queryable cursor paging provider, but this one is actually put in by default, so we can omit this. And add projections is another middleware, is another provider we need to put in. So with this, we just can say .NET run, go back to our query here, and we can see when we actually refetch the schema that we are now invalid. We could see in our schema reference that we actually have a book connection now here. And we have here these arguments, first, after, last. So we have kind of paging arguments here. And we also have now a where argument and an order argument. And we could go along. We see there's a page info that tells us about that it has a next page and stuff like that. Let's query that a bit. So let's first just see if the essentials work again. So we're just getting the title of the book. Okay, so it fetches that from the database. And you can see there that it actually just fetched the name here. And if we look at, at our output here, we now can see that the SQL statement just fetches the title, nothing more. So the projection API works now and translates the GraphQL into SQL. Huh? Damn it. Okay. And now we can maybe drill into our author and get the name of author. Fetch that. And you can see that we now get here John Skeet as the author, and everything is fine. Okay, and if we look up into our SQL statements again, we can see that we fetched title and we fetched the name of the author, and then we have here proper join. That's all provided by Entity Framework because we are rewriting expression trees on top of the queryable. And Entity Framework translates now these into proper SQL. So we get for each provider that entity framework has proper SQL for our GraphQL queries. Okay, so this is awesome. So we get all a very easy entry for our entity framework stuff into GraphQL. Awesome. But let's make that also real time. And just one annotation here. So our chocolate is not bound to entity frameworks. You saw it's just one provider that you can put in there. If you have a clean architecture approach, it works also. There are providers and ways that we can actually abstract your whole thing and be that very thin layer of GraphQL over your business layer, and still give you these capabilities of filtering, sorting where you need them. You should also be aware that you should be considerate with these filtering. If you have a lot of these filtering arguments exposed, and you essentially give the consumer the power to filter where they want, you also need to take more care on locking down your GraphQL server. For instance, Facebook, while they have one of the biggest GraphQL servers, they are not exposing it to the public. So what they do is essentially they are creating their clients internally for their GraphQL layer. And once it's deployed, it's essentially a REST layer because they're using persisted queries to communicate between their clients and the GraphQL server. Persisted queries are essentially like stored procedures. So you are sure that you can do everything with your GraphQL server during development time, but once it's deployed to the public, you only can do what is tested and was intended by your developers. But this is actually a topic for another talk that goes deeper into how you put GraphQL into production and things like that. So let's first have a look at how we can make this real time. So we actually get rid of this demo. I have another one prepared. Yeah, get rid. And that is the last demo for tonight. Just check. Okay, there are just 2 questions. I can get back to them at the end. Okay. So the last demo is about subscriptions, and it's essentially another iteration on our previous demos. So let's do restore. Okay. Okay. Let's have a look at the packages here. So essentially, it's the same packages because the subscription stuff is all referenced by this Hot Chocolate ASP.NET Core package. In general, if you don't use entity framework integration, then you just need this single package here. Okay, as I said, this is another iteration on top of what we did. So we started with a query type that get books, gets authors, maybe get authored by ID we have now. So it's a lot more query possibilities that we have in this iteration of our service. We also have now a type called mutation that is to change data, introduce, add new books, and add new authors. Let's just try that out and explore that schema a second. And then we go in and make it real time. Okay. Okay. Strange. Okay, so this is now our GraphQL IDE. We have exactly the books endpoint that we used before. It should work. Should it not? There's something. Something is wrong. Just check. That is the thing. So I put the GraphQL root on the root of the site, and that what's the problem? So actually, our GraphQL endpoint is now on the root, and I should be able to query it all. There's a second error here. Okay, I messed this up. Is it working? Not working. Let me just remove it and put it on the default. Actually worked. Well, it's not bad. And then retry. Okay, I really messed this up. Okay, yeah, green, we are good. There's something not good here. So this is actually a preview that I'm using. It should be close to the release, but I'm guessing that because I'm still working on the stuff, there was something wrong with my cache. So I'm now on the private stuff here. Let's just check if everything works, and then we can go on. Yes, it works. Okay, so there was something with my browser cache. That's why I'm just switched to private now. Okay, so you saw that we have now a lot of more operations in there. So we have not only query, we also have now mutations. So we have the queries. We can fetch a lot more things now from our root type. We also have now mutations here. We can add an author. We can add books. So let's first query maybe authors. So let's get the name of the authors. You can see there's John Skeet, Jeffrey Richter, Stephen Cleary, and Henry Troisen. I don't know if I pronounce them right, but that as it may. So this is our get authors. So we could also have a mutation. A mutation in GraphQL starts with the keyword mutation, and then we maybe have a mutation. Let's call this operation add author. And I didn't show that in the beginning, but you can have multiple operations per GraphQL document. So we can put a couple of them in here and say add author, and then provide the name of the author. In this instance, Michael Staib. I'm not really an author. I have no intentions of writing books. And then we can see we can reselect the author in order to get the ID. So there's one important aspect about mutations, because only the top level field is a mutation. So if we talk about a mutation, it's only this field. And if we talk about fields in GraphQL, fields are like methods in other languages. And so the top level field is a mutation. So this is what is allowed to mutate data. There is nothing like nested mutations. If somebody tells you there's nested mutations, it's not true. The GraphQL spec is very clear. There are no nested mutations. And this is very important because the execution engine expects that everything that becomes beneath add author in this case, comes on the next level, on the second, third level, is side effect free and can be executed in parallel without any regards to order. So I'm adding this add author here, and so this is a mutation. Everything here is a query on top of the changed state of the server. So this is changing the state of the server, adding Michael Staib. And this is me querying this changed state of the server to get the ID of the changed user. So if I fire that, then I get here a new mutation and get the ID 5 in that instance for Michael Staib. Okay. So that is a mutation, and it's essentially just like a query. Okay, let's do the next thing. Let's put some real-time logic into our last demo. So we have mutations, and if you think about it, mutations are also often the source of real-time events. So in our case, we want to have an event that is raised every time a new book is added to our library database. So I want to be able to subscribe to our system to ask to essentially be notified when there's a new book. So what we are going to is to our configuration, startup CS. Where is it? There. And we first needed to put in a real-time provider. So we can say add in memory. There's something wrong. Okay. Second, let me reload that window because it didn't properly select the solution. 1 second. Okay. So we say add in memory subscriptions, and this essentially puts in an in-memory subscription provider, essentially an in-memory pub subsystem. You can also put a hotshot Redis package in here. Then we are using Redis as a pub sub, or you can implement something else that implements a subscription provider and uses what ever there's out there, like Apache Kafka or something like this. Okay, in our case, we just have one server and we just have one system here, so we are using in-memory subscriptions, which essentially is built on .NET channels. And with that, subscriptions are supported in our schema. The second thing is we need to create this root type. Like we have a root type for mutation and query, because these are our operation types. So we need a subscription dot class, subscription class, which contains the subscription logic. And just let me grab here namespace stuff so I don't have to type too much. Okay, and we call this class just subscription. So, and this class essentially works like our other root types, so we need to have some resolvers there. So we want to have a resolver on book released that essentially is raised every time an event message book is coming in. So every time an event is raised with a payload book, we want to raise this resolver. And this resolver essentially just, in this case, very simple, returns this payload as is to the user. The second thing is that we need to tell our system that this is actually a special resolver because it's a subscribe resolver in this instance. So this is acting as a root resolver for a subscription. And we also have to tell our subsystem that we have a topic. And in this case, we are annotating this topic attribute. We could put it on something else, and we could also create the topic more complex. But in this instance, we are just saying, okay, this method actually acts also as a topic for the event. So the event would be called on book released in this instance. Okay, with this, actually, subscription is done. Which the thing we just have to do is add subscription as a root type, add subscription type. Subscription, and our system has now subscription support. but we still need to raise our subscription. So how do we raise subscriptions? I said mutations essentially raise them. So we could go to our book mutation. And essentially, after we saved our book, we could raise an event here. And this essentially we can do by putting in the event in event sender. So we are injecting a service into our resolver that is called iTopic event sender. And that is our abstraction for our pub subsystem. And that's how we can raise the event from our logic. And that is not only possible in mutations. Mutation is just the most common case. You could also raise the events from out of your service. Then you would need something like Redis that relays these events. Or you could have a background service that uses this service to raise events. Okay. And then we have here a method that is called sendAsync. We need to provide the topic, so we can just say the topic in our case is just the name of the subscription method, so on book released. We can use the name of here. Very easy to put the topic in. The next thing is the book that we just created is actually our event payload. If you use something like Redis, this might not be the best thing. Because an entity could be huge and you want to maybe have very small payloads. So you might want to just send the ID or some other related data. The second thing that we need is a cancellation token. And then we are actually done. This is how we raise our event. So let's try that out. We run that. And then we actually go into our BCP Banana Cake Pop web UI, and I'm opening up a new Banana Cake Pop instance. This is our application version. So you can have the GraphQL IDE as an application or as just provided through your server. Works both. Okay, what we are doing here is just creating another mutation. We call this get add book. And let's take our add book import here. We call the book my first book. And then let's take myself as an author. So we know I'm author 5. And let's just get the ID of the book here so we can check that everything is correctly translated to our GraphQL server. So let's just, for good measure, check that our system is initialized. Okay, it's there. And then also connect here in a new tab. To our server, we are connected. And in this instance, we are subscribing to our event. So we start the query essentially with subscription. And then we say on book released, we want to print out maybe the ID and the title of the book. So real-time events, essentially, you write them like a query. And then you just hit play. And instead of getting the response immediately, you get this waiting sign here. So it's actually subscribed now and waiting for payloads. So if I now execute this here, you can see I added the book 12. It's already here, and I can see I have my first book. And you can also drill in and just get more data or less data. So subscription is a very powerful way to write very interactive applications. Okay, I think that is quite a lot, almost 1.5 hours for you, and a lot to process at the beginning. So let's go to my conclusion. So you survived an introduction to GraphQL. we explored a lot of angles here, like what is GraphQL from the outside, where does it come from, why was it created. We also discovered what are the main reasons that drive GraphQL. For me, it's a lot about being able to iterate faster, to fetch data more efficiently. So iterate faster means the back and forth between front-end teams and back-end teams, or even between people doing data science and just trying to collect some data is so much easier, because you just put in your business model, and then people can pick and choose from that model that you provided them. And also we saw things like real-time data, how easy it is from, I mean, there's still work to be done to scaling your socket connections and stuff when you do real-time. But it's still, from a consumer aspect, it's so easy. It's you just connect to it, you write your queries, and you get the result, and you also get real-time results very quickly. If you want to go deeper into GraphQL and learn more about also best practices and stuff, I always recommend a book that is called Production Ready GraphQL. It's written by Mark Andre. It's a lot of knowledge he acquired during his career about GraphQL. And he worked at Shopify and GitHub, so the two companies that essentially went in first with GraphQL after Facebook released it. And he has a lot of experience around schema design. So it's a good book to get if you want to get more serious about building your own GraphQL server. Also, you can head over to our website to get more information about our GraphQL server. We also have a GraphQL client that also works with Blazor and stuff. And other tools like Banana Cakepop, you already saw, GraphQL IDE. And what is also what you can also find there is the link to our Slack channel, because we have a very active community on Slack that can help you quite a lot when you get started with GraphQL. So make sure to head over there. And as I said in the beginning, we will be happy if we get 1 or 2 stars out of this. If you like us, only stars if you like us, otherwise. And also do that for other open source projects you use. It's sometimes we are too greedy with our stars. Okay, with that, I'm done, and let me have a look at the questions that we have here. Hi, endpoint. Hi. I have a question. Endpoint person had in its declaration 2 parameters, ID and person ID, and you called it just with ID. What is the meaning of the parameters? The person endpoint. Just let me have a look. You mean the initial GraphQL API? I actually have no clue. So if it meant the initial swappy, let's go there. Swappy GraphQL. This is really the official example of the GraphQL Foundation. Interesting. I didn't see that, because we are actually at the moment we are almost ready with version 12, our new GraphQL server version. And we are building at the moment a new Star Wars project that is more complex, and that shows also off how we can do it with entity framework and stuff like that. I just grabbed now for the official example to test for this specific talk. Okay, so what they do here, but you actually don't have to do that. So what they do is they have the clean int ID here, where you can pass in the int, and they have the global unique global unique ID, which is you could say the relay global ID, which is the base 64. Hot Chocolate actually allows you to use both versions in the same field. If you can swap out our serializer and then allow both formats in the same field, so you don't have to have two arguments here. But that was a good catch. It had made my demo easier because I actually didn't want to introduce the whole global ID concept in this introductory talk about GraphQL. Are only subscriptions as root allowed without a query root? I cannot follow this question. In which circumstances would you use REST APIs instead of GraphQL? Okay. There are not a lot, so I do most of the stuff with GraphQL actually when we build APIs, but we have a high frequency telemetry API, and that is actually done with REST. It's a very small payload, a high frequency API, and GraphQL just doesn't make sense there. It's also a very technical API. There are maybe some other instances, because there are actually some other instances where you also can take GraphQL and expose this GraphQL as a REST endpoint for some other tools. Maybe you have tooling that wants REST. It's also, if you think about GraphQL, and when I talk about GraphQL in production, I'm always recommending using persisted queries. So there are two types of GraphQL APIs. There's something like GitHub, and GitHub actually cannot do persisted queries for their public endpoint because it's public. People want to query it, they can do anything with it. So with these public endpoints, you have to think about cost analysis and query complexity analysis and stuff like that to make sure that you have a consistent performance over all kinds of requests. But when you put GraphQL to production in a case where you are in control, like Facebook only uses their GraphQL API by themselves. They are actually not exposing GraphQL to you. The Facebook Graph API is actually a REST API that some kind is constructed, I think, of the GraphQL APIs. So what they are doing is essentially persisted requests. And what you have on production is actually a REST endpoint where you have fixed requests. So kind of, if you use GraphQL, you're also using REST in many cases, but a more optimized version. But that's a bit philosophical. So I have rare occasions where I use REST, but I can see there are still some cases where you want to use it. Okay, there's also some discussions. I'm just skimming through your questions. What if I don't want to expose as GraphQL endpoint full EF context, but only my domain model? Excellent question, Thomas. So this is an introductory course. That's why I'm going for the low-hanging fruits. And but this also every time gets some confusion. So when I show Hot Chocolate together with entity framework, like sitting on entity framework, I would say that's the rapid development approach. People just taking their database and exposing it through GraphQL. If I'm building a GraphQL solution, I most of the times, and I show that in the initial diagram, you have this thin layer of GraphQL sitting on your business layer, on your domain layer. This is how Facebook does it, and this is a good way to do it. So you don't have to put GraphQL on your entity framework layer. But there are different types of developers, and there are different types of approaches to building software. So you can go about it as you wish. We are not demanding one way or the other. So if you go entity framework, we allow you to do that. You can take entity framework and just expose it through GraphQL. You can take your domain layer, clean architecture. You can take that, and we have invested a lot of work that it works very nice with Hot Chocolate, and you can also put this nice thin layer of GraphQL over your domain logic, so over your domain layer. So there is no stopping you doing that. Yeah, it's not hard to do that. So you can do that. There is a bit around like if you wanted to achieve those filtering stuff. This version 12 we allow you to intercept these filters and then pass them onto your business layer or your domain layer and then interpret them there. And essentially, we give you the filters on top of your business types, and then you can translate them however you want to a database, to whatever, or what have you. So what is the recommended way of dealing with errors? Okay. So that is, I would say, another talk. So there are a couple of best practices in GraphQL to deal with errors. So there are developer errors. Let me show you a developer error. I'm typing something wrong here, like name. Doesn't exist. I'm sending that to my Graphql server, and I get this error result. And this actually, with the new GraphQL over HTTP spec, would be also giving you an HTTP status code 400, because there's now a bad request, because that is not passable. The server cannot do something with it. Typical developer error. So GraphQL will write an error collection here. There are also other typical developer errors that we have, like in GraphQL, like the database is not there. Connection string is wrong. Something unexpected. Something that is not an expected error. And then there are things like you are writing a mutation and you're feeding in the wrong ID. Or you're adding a book title and the book title is too long. Or you're adding in a serial number for something in a mutation and it doesn't conform the format. And these are actually errors that are user errors. And user errors are exposed as objects in the schema. So you would design these errors on your mutation responses. And then the consumer of the API can take these errors and translate them into something in their UI flows to react to it. Maybe if the format is wrong, we are rendering a red box around your field and stuff like that. So there are user errors, and these user errors are just part of your schema. And there is the book I showed you, Production Ready GraphQL. The author, Marc-André, and let me just look that up for you, has written a nice blog post on GraphQl Errors. So he essentially took all the approaches that existed out there. So he didn't just invent them, but he went through the stages of GraphQL errors, how we used them, and how different companies used them, and went through them and outlined pros and cons. So this is a very good article if you want to go into these error topics. So this essentially is the developer errors I showed you. Then there is maybe errors in the payloads, something like that. And you can see, so what Hot Chocolate is working on is making the stage 6A, and I think that is the best way to do it. And this is this one here. To expose errors on the schema. We're making this very nice and very easy to do. So we're working on that. Maybe version 13, it will be just be very easy to do that. At the moment, it's a couple of types you have to create. Like you can see, we have a union type. This is actually the error that is exposed. Then you have an interface that represents the error, and so on. But he explains which error approach is good and bad. Like you have the pros and cons, like here, easier evolution of the schema, support for multiple errors and stuff like that. So this is a good read, and I can just post that here to my host on StreamYard, and he can maybe relay it to you in the chat. Okay. The next question. Hold on, you can use that. Okay, that's an answer to something else here. Okay, how do you go about creating mutations against EF relationships? Create an author book and relate them. Can be done in one mutation, or should be mutations. Okay, so this question is about if we have related object graphs, and you want to create essentially an object graph, like you want to create the author immediately with a couple of books. And there are also multiple approaches to do that. So you could either do, like I had 2 mutations. I'm creating the author, then getting the response and feeding in the books. But it's also a good approach to have mutations. Like you should actually use it. You should look at your use cases, and if your use case is to always have the author with the book together, you should incorporate that in your mutation and create 2 input objects, one book input and one author input, that represent actually the structure of your type, so you can fill up this data tree directly in a mutation. But also this, a good thing in the book here, that the production-ready GraphQL, he outlines those patterns. I have another talk about this, also about schema design, that goes more into those pattern and approaches. But it's definitely, you can create those input structures and then have really your mutation done in one step. What you should not do is just create a CRUD API with GraphQL. Be specific about your use cases. Think about what are the actions that you're really doing against your domain layer. So while also in this introductory talk, I had just add book, add author. It's not very explanatory how you should build a GraphQL API. We actually have a good tutorial. So this on GitHub, and let's go to hot chocolate. And we can just dive into that docs, and then we should have, I think down here, a link, to our GraphQL tutorial. It's a GraphQL workshop, and this is a bigger workshop that goes through a lot of concepts. We are at the moment reworking it for version 12. But still, you can go through it in version 11. And it also tells you about mutations and stuff. So it goes through a lot of concepts, and also tells you about here real-time, filter capabilities, what middlewares are, how they work, and also this schema design section. And I think that goes also into the topic of mutations. So there's a lot in here that really explains how you can do that, and how you can design mutations. Also, this is done on top of Entity Framework, so there's no domain layer. But if you would do that in a tutorial again, it would be too much. So this is a good address. So if you go to our website, docs, let me just show you the way. Go to the docs, then go to get started. And down here, you find a GraphQL tutorial. And with that, I think I've answered all your questions.
I have one more.
Okay, shoot.
It was touched on a little bit with the error objects, but can the responses be polymorphic? If I'm returning a list of characters, can I override the base types and have different properties on?
Yes, you can. So I didn't show that in my initial example, but let's have a look at. So we have this workshop example from the tutorial. Can access it also. So this is a workshop ChilliCream.com, and that has more. Do we have that implemented? I'm not sure, but I can tell you. I can show you the concept of how you can go about that. Let's say we have a list of nodes here, a list of tracks actually. So this is just selecting objects. So if you are talking about polymorphic objects and different types, I actually don't have a lot of types here, but it's the same concept. You're using fragments to select these types. So I could say, okay, when this type is a track, then display the name. But if the type is something else, then do that. Oh, we have something like that. There's one field here. So that's a node field. It's a special field. So let me just show you. No, this thing. You just need an ID, and then I can probably show that. So I'm grabbing this ID, and this is one of those global IDs. Global IDs can be fetched through the node. And node actually is an interface. So this node field returns an interface. So I can fetch any node from my graph and get that. And what you can see here is that node, the interface, let's just go into the schema reference and look for node. You can see this is an interface, and it just has an ID. And if we go, for instance, to our track type, you can see it implements node, and it has the ID, but it has also a couple of other fields. So when we are here, we just have two fields. We have type name and ID. And if we select that, we just get just the basic fields. That's the interface. But we can use now fragments to, for instance, say, okay, if this is a track, so then I actually want the name, and I also want the sessions. And from the sessions, I want maybe the ID, just to make it more. And I can fetch that, and you can see, and now I get all the properties because it knows this actually is a track. So now you asked for polymorphic lists. So there's this nodes field. It actually allows me to fetch now multiple things. And now I'm not only fetching the track, but I also fetch the session here. Again, in this case, we would get, you can see now it's a list. We would get here the node, which is interpreted as node, but then here's a session, and okay, we have no case for session. But we actually could just add that. So if it's a session, then we actually want the title. Fire that, and you can see now we have a title here and just the data down here. So this is how you select the different cases, and there are different ways to do that. So there are interfaces and there are union types. In .NET, you don't have union types, but you can still express your .NET code as union types, which is when things don't have anything in common, like ID. And you can also combine them, like have a union that exposes objects that also are representable to interfaces. Okay, there's one more thing, because that can become quite messy here as a syntax, and maybe you want to reuse this data shape. When I started this talk, I talked about fragments. This is an inline fragment. But when you actually write up your queries, you would define these reusable shapes for composition here. Like you would say, okay, this is maybe my track name. I could call it has track name, goes on track. Track. And just exposes maybe the name. And then I maybe have a fragment track with sessions on track. And this essentially gets track name, and then we could take the rest. This guy, put it here. I don't want it. And then we might have another thing, which is like a session info on session, and this exposes you just the title. Session has a title. Okay. So now we can get rid of these guys and actually make this very nice readable, because we can say, okay, this is actually this guy here is track with session, and this guy is the session info. And you can see how you really can compose these results, and it's the same result. You can see nothing changes, same result, but now a bit more readable and composed into multiple things. And if you were building a large client applications, often you would have these fragments embedded maybe in your JavaScript or in a separate file, and you would merge these queries out of these fragments. But this is a way how you deal with polymorphy in GraphQL. Does that answer your question?
Yeah, very much so. Nice. I was going through the comments, and there are no more questions. There's some thumbs up and people saying that hot chocolate is awesome. So
nice.
Thanks for that. Thanks for the talk, making our lives a little easier with consuming these APIs.
Yeah. Thanks for having me.
Hopefully catch you up in the update conference in person here.
Yeah, and then we are talking about GraphQL with Azure Functions, very new. We hadn't support for that yet, but update conference, Azure Functions and GraphQL.
And looking forward to the next version.
Yeah, you're welcome.
All right. Thanks a lot, Michael. See you next time.
Goodbye.